So today we're going to talk about integration by substitution. So before we get into any of the topics, really the process we're looking for is we're going to be looking at replacing part of what we're given with what we're going to call u. This process is called u substitution. And that whatever that part is, then the derivative of that is also part of our function. Now that derivative can be off by some value of a coefficient. Otherwise, it's going to need to appear in the function itself. So there is a procedure for using this u substitution method of integrating. First, we're going to look for a piece of the function whose derivative is also in the function. And if you're not sure what to use, we're going to try the denominator or something that's raised to a power in the function. We're going to let u equal that piece of the function and then take the derivative of it with respect to the variable. And we're going to call that du. We're going to use our u and our du expression to replace portions of the original integral, and now that's just going to make it easier to solve. You can kind of think of this substitution method for integration as like the chain rule for differentiation. So the substitution method for indefinite integrals is going to look kind of like the following. Substitution is just a method for integration designed to undo the chain rule. It generally involves 3 steps. So if we're given the integral of a function, of a composite function, multiplied by the derivative of our inside function, so integral of f of g of x times g prime of x, chain rule, with respect to x, the first step, we're going to let u equal g of x, and then du is going to be the derivative of g with respect to x. Then we're going to find the antiderivative of f, and we're going to call that big F of u plus a constant. And then we're just going to plug u, the expression we said u is equal to, back into the equation, back into the function. So as a little recognition of a pattern that would go on, we can say that the outside function is going to be f of x, g of x is our inside function, and the derivative of our inside function is g prime of x. Really all we're going to be doing is right here on the screen. So let's look at some examples. So our first set of examples, A and B here. We're going to focus first on A. Now when I look at this problem, the integral of x squared plus 1 quantity squared times 2x dx, I'm going to say I know u can be whatever I have here in the parentheses, because if I take the derivative of x squared plus 1, if I find du, that's going to be 2x with respect to x. So now I'm going to just replace parts of the problem. So we're going to be taking the integral of u squared du. And that's a lot easier to find the integral of. We're going to increase the power of u by 1. So we're going to go u to the third, divide that by 3, and then we have to add c to it. But now what we're going to do is we're going to replace u with what we said u is equal to. So we're going to put x squared plus 1 in for u. So we're going to have x squared plus 1 to the power of 3 divided by 3 plus c. And that is going to be our answer to example 1a. That's it. Now when I'm looking at b here, I'm going to let my u equal whatever's inside the cosine. So I'm going to let it equal 4x, because if I take the derivative, if I find du, I'm going to just get 4 with respect to x. So I can rewrite this integral. I can write this as the integral of cosine u du. Now when we take the integral of cosine, we're going to just get sine. So this is the sine of u plus c, and we said u was 4x, so we're going to replace u with 4x. So we're going to have the sine of 4x plus c, and that's going to be our answer to that integral. Let's look at a couple more examples. So still in example 1, but this time we're looking at parts C and D. In part C, if I am wanting to come up with a u value, I'm going to take what's inside this square root. I'm going to go 4x squared plus 1. And then I'm going to take the derivative of u and get 8x with respect to x. So now I can rewrite this as the integral of the square root of u, which I'm just going to rewrite as u to the 1/2 du. Now I'm going to increase that power by 1. So I'm going to have u to the 3/2, and now we have to multiply that by the reciprocal of 3/2. So we're going to multiply the u by 2 and divide by 3, and we have to add c. So we're just going to replace u now. We're going to have 2/3 times 4x squared plus 1 to the power of 3/2 plus c. And that's going to be the end of that integral. Let's do a couple more together. When we're looking at this next part, part D, I'm still going to take what's inside parentheses and call that u. So I'm going to go u is equal to x squared plus 2. Then when I find du, I'm going to get 2x dx. But that is not part of our original function. However, I can make it be part of it if I divide everything by 2. So if I rewrite this as 1/2 du equals x dx, x dx is part of that original problem. So now I'm going to rewrite this as the integral of u cubed du, and I put a 1/2 in front of that integral. So now I'm going to integrate what I have here. We're going to have 1/2 times, we increase the power of u by 1, so u to the 4th, divide by 4, and we throw a plus a c at the end. Now all I'm going to do is replace u with x squared plus 2. So I'm going to go 1/2 times x squared plus 2 to the 4th over 4 plus c, and I'm almost done. I'm actually going to multiply the 1/2 into what I have in parentheses. 1 times x squared plus 2 to the 4th is just going to give me x squared plus 2 to the 4th, and then 2 times 4 is 8. And then I throw my plus c at the end, and we're done with example 1D. let's keep this integration train going. Alright, moving on to E and F. We're going to have the integral of x over 4x squared plus 3 to the power of 6. So in this one, again, with what's in parentheses, that's what I'm going to let u equal. So u is going to be 4x squared plus 3, which means du is going to equal 8x dx. Okay, but that's not in the problem. I can, though, divide by 8, just like we did in the last example, and make it 1/8 du is equal to x dx. And now we do have an x and a dx. So we can rewrite the integral. We're going to have 1/8 out in front. That's just a multiple. And then we're going to have 1 over u to the 6 du. I'm going to rewrite this. I'm going to make the 1 over u to the 6 as just u to the negative 6. Which makes it a little easier to integrate. We're going to increase that power by 1. So we're going to have 1/8 times u to the negative 5 divided by negative 5 plus c. Now I'm going to replace my u. We're going to have 1/8 times, in fact, I'm going to at the same time bring that negative power down. So 1/8 times 1 over negative 5 times 4x squared plus 3 to the 5th plus c, and I'm almost done. I'm now going to, so now we're going to multiply that 1/8 through. So our final answer to this problem is going to be 1 over 8 times negative 5 is, we'll just make the 1 negative. 8 times 5 is 40 times 4x squared plus 3 to the power of 5 plus c. And that's going to be our answer to E. So let's check F out. F, I'm going to let whatever's in the parentheses within the square root be my u. So I'm going to let u equal 7 minus 2x cubed, which means du is going to be negative 6x dx, but we don't want that. In fact, I forgot to put an x squared. We don't want that 6 there, so we're going to divide by negative 6. Make this negative 1/6 du equals x squared dx, because I did not have a negative 6 x squared and a dx outside of that square root. Alright, now let's clean this up. We're going to have the integral of the cube root to the 4th power of u. So I'm going to just go u to the 4/3. And then out in front, I'm going to still have a negative 1/6. And then I'm just going to put a du. So I'm going to increase the power. I'm going to write negative 1 over 6 times u to the 7/3. In fact, I'm going to give myself some space because I know I have to multiply u by something. U to the 7/3 plus c, and the thing I multiply u by is the reciprocal of its power. So 3/7. Now I'm just going to multiply slash simplify the fractions here. 3 and 6 can simplify to 1 and 2. So I'm going to end up with negative 1/14. And I'm going to replace u now with what I said u is. So 7 minus 2x cubed to the 7/3 plus c. And once I've done that, I can be done. Alright, let's check out a couple more. Alright, so g and h. We have the integral of cosine x times the square root of sine x plus 2. So I'm going to go u can equal the sine of x plus 2, because I know when I take the derivative then of u, I'm going to just get cosine x with respect to x. Cosine x dx. So we can rewrite this integral as the integral of u to the 1/2 du, which means we're going to have u to the 3/2 times 2/3 plus c when we take the integral. Then we're just going to replace u. So we're going to have 2/3 times sine of x plus 2 plus c. In fact, that sine of x plus 2 is also raised to the power of 3/2. Once we've done that, we're done, and we can move on to h. H, we've got 12t squared, the integral of 12t squared e to the 4t cubed. So this time I'm going to let u be the power that's on e. I'm going to let it be 4t cubed, because when I take du, I'm going to have 12t squared dt, which is part of my function. So I'm going to take the integral of e to the u du. Now we learned integral of e to the u is just going to be e to the u. So we're going to have e to the u plus c, but now we can replace u with the 4t cubed. So we're going to have e to the 4t cubed plus c. And we're done with that one. Alright. I think we've got time for 2 more examples. So let's for sure do one more. We'll see if we have time for a second in this video. We've got the integral of the natural log of x over x with respect to x. So I'm going to take and let u be the natural log of x. Because when we take the derivative of that, derivative of u, we're going to get 1 over x dx. So we can rewrite this now as the integral of u with respect to u. Now we'll just increase the power of u by 2, by 1, make it u squared over 2 plus c. So we're going to have the natural log of x squared over 2 plus c for that integral. And we're done. I think we have time for one more. So in this next one, I'm going to let u equal the cosine of x. So when I find du, we're going to have the negative sign of x with respect to x, but we don't have a negative sign, so we're just going to multiply everything by -1. Make it negative du equals the sine of x dx. So we can rewrite it as negative u to the 4th du, which means we're going to have negative u to the 5th over 5 plus c. And then we're just going to replace u. So we're going to have negative cosine to the 5th x over 5 plus c. And we're done. And we'll continue our lesson in our next video.